Okay, so similar, that's the symbol for similar. And the thing that you need to know about similar figures is that these are going to have the same scale factor, right? So 8, the scale factor here, 8 times 1.5 is the scale factor. I'll show you how to figure that out in a minute. Is going to equal 12, right? So this is corresponding sides. It will be the same. So like 12 times 1.5 will give you 18, all right? And 10 times 1.5 will give you 15. The scale factor should be the same all the way around, or it's not similar, okay? The angles, though, are congruent. They are the same. So if I tell you, for example, that angle A, let's say is, I don't know, 88 degrees, that means angle F is also 88 degrees. Angles will be the same or congruent. Side lengths will be what we say are in proportion, okay? So have the same scale factor. All right, let's do how you do this. So finding the length of a side. And you're going to use scale factor or use proportions to be able to do this. So this is like on an SAT question, right? It'll say find the length of a side. And it says this, the way you read this is, in the diagram, triangle ABC is similar to triangle DEF. Okay, great. That's good to know. What is DE? So you're looking for this side length to figure out what the length of it is. Now, you can either figure out the scale factor or you can use a proportion. Here's how you do this. So you got to start with what a corresponding set that has both numbers in it. For example, BC and EF correspond to each other, right? So those we can line up in a proportion. So BC is on my left one, so I'm going to put that on the top, on the left side. And then 12 is on my right figure, so I'm going to put it on the top of the right. I'm going to line them up. And now the one that I'm trying to find here is AB, right? Or I mean, sorry, DE. So AB is 10, that's on the left. It lines up with DE, that's the one we're trying to figure out. So we make that X. And then we use what we learned yesterday to figure it out. Okay, how do you solve this proportion? Xavier, what do you do?
You cross multiply 16 and X.
Yep. Cross multiply 16 and X, so 16X, and then equals what on the other side? 120. And I told you guys you could skip that step, right? If you know 10 times 12, just go ahead and put 120. And then what do we do?
Divide
By what?
16.
Good. We divide by 16, and X equal what? What is it?
7.5.
And that's the correct choice here. So choice A would be our choice.
I like that multiple choice.
Yeah. Yeah. Okay, so that's the reason, really, one of the reasons we were learning proportions yesterday is to do this. All right, let's do it again. So this is how you apply it. And so if your copy is a little bit hard to see, I'll write these in, okay? They're X, the X feet they have here on the building. This is X feet right there. Oh, you still can't see that very good. X feet. Okay, so the question is how we use indirect measurement. And you can do that using shadows. So the sun rays strike the building and the girl at the same angle. So if the rays are going at the same angle, whoop, then your shadow should be similar, right? So you're going to have two, they really form like a triangle. How tall is the building? So what you do is you use the shadows, you can measure those shadows and the height of the person that you know to figure out the height of the building without actually directly measuring it. So you set up a proportion like this, all right? And I like to set them up like left with left, right with right. So on my left side, the shadow is 3 feet. So I'm going to do the shadows here on the top. What's the matching shadow then on the right side? 15 feet. Now I'm back to my left side. On my left side, I'm measuring a woman. She knows she's 5 feet tall, so that's what's going to go here, all right? So this is our actual. And we don't know the height of the building, so we use that as x. And we cross multiply like we did the last one and divide, okay? What gets multiplied? 3 and x, okay? So 3 times x. Equal now 5 times 15, which again, you can do that. What is 5 times 15? What is it, 75? Okay, and then we divide. So x equal 25 feet. That's how you can measure, especially like stuff that's really tall and dangerous to measure by doing it actually. You can measure it using shadows. It's kind of nice. All right, so far so good? Beautiful. Turn the page. This one has 2 pages to it because there's a lot of pictures, right? And so I had to use extra space so you could do the pictures. All right, the next one, the next section is scale drawings and scale models, okay? So scale drawings are usually like maps, right? So a map is really a scaled down version of an actual piece of land, right? And so the way they do it, usually you see a little key, see it right here on this picture, where it tells you the scale. So this key is saying the scale for every 1 inch on this map represents 110 miles, okay? And so you can use proportions to figure out the actual distance. And so on here, it says, what's the actual distance from Jacksonville to Orlando? Use the ruler to measure. All right, so here's Jacksonville, if you can't see it that well, at 0. They've lined a ruler up for you. And then here's Orlando down here. What's the measurement down at Orlando using that ruler? What's that measurement? What is it, Nathaniel?
It is 1.5.
Yeah, 1.5 inches is the measurement, okay? And so what you do, and I think there's multiple ways to set this up. What I feel like is the easiest way is to set up a proportion and put the scale in the first one. Because normally you get the scale, but sometimes you're asked to figure it out. So 1 inch on the map is equal to 110 miles. I put the scale in the first one. Now, you can do it in the second one, too, if you want to. It'll give you the same answer. And then you fill in your other piece of information. 1.5 inches should go where, then? Top or bottom? Yeah, top. It's got to line up. So this is the map, right, on the top, and the bottom is telling our actual. And so this is x. Now, the nice thing about scales and maths is it's usually compared to 1. So if you multiply this times this, right, and this times this, you get 1x equal, what's 110 times 1.5? 110 times 1.5 is?
165.
And so technically on this scale one, when you divide, especially when it starts with 1, you're dividing by 1. Which is awesome because then you get just that, 165 miles. And you might want to know that, especially when you get to driving, right? Because some of that, if you guys take a cross-country trip, depending on where you are, there could not be a gas station for a long time, right? And so if you don't know how far you're going and you don't know the distance between gas stations, especially, like if you're traveling through the desert, that could mean life and death for you, right? So you want to figure out that stuff. Now, there's technology now that really gives you those answers, but it's important to know how they actually do it. If you put in a GPS, that's what they're doing, okay? It's doing proportions in that GPS. All right, last one then. The last thing they that we use the proportions on in this is scale model. So if you ever walk into like a museum, they will make like representations of stuff to make it bigger so you can look at it, or even like something as simple as like an action figure, right? They like do that, they scale it down so that it can represent, or like what is it? What, like a scale little car, a model car, or what are they called? What are the little cars that they're called that I'm thinking of? Hot Wheels, yeah. They use proportions to make sure the Hot Wheel looks like an actual car, all right? And so here's what we got. A giant model heart is shown below. The heart is the ideal size for a person who's 170 feet tall, like the Jolly Green Giant, right? They blew it up. About what size would you expect the heart of a man who's 6 feet tall to be? Now, it's important to note that they say the ideal size of a heart, not everyone's hearts are going to be the same size, right? But that's how, you know, we figure out if there's something wrong, right? Is if your heart is too big, you could have a heart attack right on the basketball court. It has happened to young people. But anyway, that's medical, and that if you're going into medical, it's important to know how to do this. All right, here we go. So here's what we have. Our information here, and I like to line it up. This is our actual heart. All right, so I'm doing my hearts on top versus the height of the man, right? And so he's 6 feet tall. What's the size of the model heart? 14 feet. And how tall would the man have to be who had that heart? 170. It tells you in there. And so once you set this up, the important part is to label, right? So you know what goes with what, and then solving the proportions, the easy part. So 170x equal technically 14 times 6, which would be what? 84. All right, and then what do we do?
Divide by 17. By 170.
What does x equal? You should get a decimal.
0.494.
So about 0.5, right? Okay, so think about this. Remember, this is in feet. So the heart is about how many inches then?
6.
About 6 inches for that guy. 6 inches. And that makes sense, doesn't it? Okay? That's how you do this. Okay, are there questions? All right. So that is the lesson, right? We have here, not 2-7, just kidding, 2-8 practice that we're going to work on. I'll help you guys get started. And then hopefully if you are a person at home, that you can come in and grab that worksheet so that you can get caught up.